start with our second module, sensor and transducer. In previous lecture, we have studied about what is meant by transducer and sensor, its basic definitions, then active and passive transducer, then selection criteria for the basic transducer, that is depending upon the characteristics of the transducer, and then we go to the different factors while selecting a transducer. Now today we start with the displacement and pressure transducer. First, in part 1 we start with the displacement transducer. Displacement transducer, that is nothing but the potentiometer. So potentiometer, it is a displacement transducer. It is basically, it is called as electromechanical transducer. So why it is called as electromechanical transducer? It is called electromechanical transducer. So why it is called as electromechanical transducer? Because it converts mechanical energy into electrical energy. So it is called as mechanical transducer. So here the mechanical energy is nothing but displacement. And which is an input to the potentiometer. And the output energy form, electrical form, that is the voltage. That is the voltage output form. So potentiometer, it is called as electromechanical transducer, which converts mechanical energy into electrical energy, where the input is a displacement and output it is your voltage. So this is called as your electromechanical transducer. Now it is also called as error detecting device. It is also known as commonly error detecting device. It is a basically application in control system. So it is also called as a mostly error detecting device in control system. So here the error will be detected between the difference between output and input of a system. That is nothing but which will be used as an error detecting device. Where this error will be detected, this is the difference between your output and input system. That is called as error detecting system. The potentiometer basically classified into two types. One is translation or linear potentiometer, and second is rotational potentiometer. Now this classification is depending upon the displacement type. First one is linear means translate. So classification of potentiometer, commonly it is called as a pot. So potentiometer basically classified into two types. One is your translation or linear potentiometer, and second one is called as your rotational potentiometer. So classification of potentiometer under the category of their displacement is a translation or linear potentiometer or rotational potentiometer. Now we see the basic structure of potentiometer. First we see the basic structure of any potentiometer. The basic structure of any potentiometer consists of two terminals. That is, one terminal, it is called a fixed terminal, and second one terminal, it is called as your variable terminal. So here the fixed terminal where the input voltage is fixed terminal, and here this is called sliding contact, that is called basically wiper, and this is a variable terminal. So potentiometer consists of two terminals and one sliding contact. The sliding contact basically is called as a wiper. Now we are going to the translation of linear potentiometer. A translation or linear potentiometer, when the input voltage is applied at a fixed terminal, that time the displacement, which is a variable form, which is applied to this sliding contact, and the output voltage is given. So according to the displacement, the output voltage will be variable. Now see the block diagram for the translation. Potentiometer, here the fixed terminal, so here input voltage, that is fixed terminal, we apply the input voltage E YT, it is yi, it is a linear displacement of a wiper from its initial position. This is a wiper, and here the E0, that is output voltage, will be measured. So this is a E out. So in the input voltage applied to the fixed terminal and the displacement which is provided here. So the variable output voltage is measured. So variable output voltage measured at the variable terminal and displacement is converted into voltage. So that is your translation or linear potentiometer. So in under ideal condition, the relation between input voltage to the output voltage is given by the ratio, that is E out is equal to E in is equal to, that is yi divided by yt. So here yi is a displacement from the zero position. So yi is a displacement from zero position, and yt is a total displacement or we can say the total length of this translation potential. Total length. So here we can see, so the under ideal condition, the relation between input and output voltage with their respective displacement is given by E out upon E in yi divided by yt. So yi is a displacement from the zero position or initial position, and yt, it is a total length of this translation potentiometer or total displacement. So this is the equation under ideal condition. Now we are going to the next type of the transducer, that is potential transducer, that is a rotational transducer. So second type, it is a rotational potentiometer. Again, input voltage applied at the fixed terminal, that is denoted by E in. And the output voltage, which is measured at the variable terminal, that is E out, which is measured variable output voltage at the variable terminal, where theta I and theta t. Theta I is an input angular displacement. Theta I is an input angular displacement, and theta t is your total length of a wiper. Theta t is a total length of a wiper. So the relation between under the ideal condition between its input voltage and output voltage, that is can be given by E out is equal to divided by E in to the theta t divided theta I divided by theta t, where theta I is a total angular displacement on the input, or the theta t is a total length of a wiper. So here the displacement input is a displacement input is a displacement, now output is your voltage. So input angular displacement and theta t is a total length of a wiper. Total length of a wiper. So this is the relation between the rotational transducer in terms of the input and output voltage between its angular displacement of an input and total length of the wiper. Now, what is the application of a potentiometer? Basically, the potentiometer will be used for the error detection purpose between two shafts. So application of a potentiometer it is used a error detecting device in control system. It find out the different distance between two shafts. It find out the distance between two shafts. So this is an application of potentiometer. Now, what are the advantages of a potentiometer? That is, first, it is inexpensive and simple to operate. So what are the advantages? Advantages of potentiometer. So first, it is inexpensive. Simply put, it is a low cost. Its operating is very simple. Its operating is very simple due to its construction. So means we can say that the construction is very simple. Construction is simple. The circuit is in simple format. So this is an advantage. So first one is inexpensive and second one is the operation is very simple. And third one, you can say that the drawbacks or disadvantage of potentiometer. So these are on the potentiometer. It requires more force to move the wire. So wiper means there is a sliding contact. Okay. So this is the all about your potentiometer and its types, definition, advantages and application. So we can stop here. Thank you.